For those of you who don't know me, my name is Robert Lindsey. I am the Senior Network Engineer for the South Carolina Education Lottery. The fact that I am the only network engineer for the South Carolina Education Lottery can be ignored at this point. This is a presentation about the network monitoring system that I have been building over the last 8 some odd years. It started off as gee, I've got a heck of a lot of stuff I need to watch here and I have no way to do it. So I had to use whatever tools I was able to put together, whatever tools I was able to find. And this is pretty much a description of what I wound up with. I would like to note that the system described herein is not and was never intended to be a complete, comprehensive, neat package. All of this began as an accumulation of zero-cost tools on cast-off equipment tied together in a loose structure with the sole goal of helping me do my job. Emphasis on help. It should not be viewed as a solution and certainly not a standalone system you can install with a few clicks of the mouse. It is just a way to automate a lot of the minutia that I would otherwise have to spend my time coping with in other ways. Also, it is not a description of my entire NMS system, just those parts I am comfortable sharing. The complete system includes multiple IDS and IPS systems, as well as separate vulnerability testing systems, penetration testing systems, antivirus and anti-malware systems, and log analysis packages. Most networks are closed books. Often, no one knows what devices are connected, or how they are configured, or what traffic they are putting onto a network. Documentation, if it exists at all, is usually outdated and always incomplete. Therefore, the first objective of any monitoring system is to determine what is on the network and what it is doing there. In this way, the NMS can be at least partly self-documenting. Once you know what you've got, then you move on to deciding what parts of it are important and need to be watched closer than simply learning when something breaks. Indeed, the goal should be to establish metrics for the critical functions and set agents within the NMS to check them and report when something deviates from what you have determined to be their normal operating ranges. Any aids that can be focused on this in an unobtrusive way to reveal the otherwise invisible performance characteristics of network infrastructure and host systems should be considered. Anything that will provide information with a sufficiently low signal-to-noise ratio should be employed. Design strategy. My network monitoring system wasn't so much built as it was assembled. Writing everything from scratch has an appeal in that it gives you total control over the finished product, but is rarely a good use of time when there is so much prior art in the field and so many useful bits that can be adopted, adapted, or simply operated in parallel as a redundant measure. Indeed, the core design principle of this system is multiple repeated redundancy amounting to overkill. While this may at first glance seem wasteful, it allows for a higher level of sensitivity, leading to a larger number of false positive alerts.
Hey, Robert?
Yes.
I'm sorry to interrupt you. I'm assuming you have gone past the first slide?
Yes.
Okay, we're still seeing just the first slide.
Oh, hold on. Hold on. Okay, are you seeing the smaller slide now?
I'm seeing what is it, Open Office?
This is before you hit F5 to make it big.
Yes.
So you are seeing that, okay?
I'm seeing network monitoring, Robert Lindsey.
Yep. Okay. Well, I mean, do you see the Open Office building stuff on, properties on the right and slides on the left?
Yes.
Okay. All right. Now you see it big?
No. No, I do not.
Okay. All right.
I wonder if
I think. Okay, I see your mouse.
You see the second slide?
Necronomicon.
Yeah. Okay. Man. Well, apparently Google's not picking up on moving the slides from one to the other. We could open up in PowerPoint. I got that.
Try that.
All right, Jace, what do you think about opening up in PowerPoint instead of OpenOffice and trying that?
Sure.
Or do you just want to go ahead with the smaller stuff here?
I mean, that's fine. If we can advance the slides, either way is fine, really.
You can expand the screen, eliminate the properties window.
Change the layout over here.
Here we go.
There you go. That's, yeah.
There we go. This is better. There we go. Okay. Oh no.
Can you change?
Yeah.
Can we
still got control over the.
All right. Use
Outline.
that's right. No. Use slide sorter. Nope.
Maybe it's under toolbars. Under view and toolbars.
Left, right, and up, down, don't work on that.
View.
Try
Just
to up and down or left and right arrows and see.
Oh, yeah, that's position.
Oh,
page up, page down.
you don't have it on my. Okay. We're trying to figure out how to advance the slide from here.
Okay. Are you doing a split screen, or are you doing?
Well, I made the mistake of throwing away the outline page and now it's all right.
Oh, and by the way, I know you're live, but are you recording us also?
Yeah.
Okay.
Yeah, it's doing the Google error.
Hey, Internet.
Yeah.
Can you see the second slide?
Can you see the second slide now? Necronomicon?
Still Necronomicon.
Oh, that's good.
Yes.
All right, see the wires?
The wires? No, I do not see wires.
Gee, what the heck is going on here?
Well, the Necronomicon.
Your mouse is not moving also. Now it's moving.
Now it's moving, and you can't see the wires.
I can see the Necronomicon.
Ah!
Bizarre.
All right, well, apparently they built it for...
There's cables.
Okay.
All right, well...
How did you change it?
I don't know.
Into, back out of, and then.
This is bizarre.
There has to be a way to change slideshow here.
Select. It's got to be view. It was the slide sorter that I had, so if I view it.
Drag it to the left.
Well, that hides it. Okay, here we go. It's not like that at all.
You gotta go back to normal. And then it's a dock somewhere.
Jason, you know how to advance slides from inside Office when you don't have to do a slideshow?
No. I don't use Office products.
No, I'm talking about LibreOffice.
I don't use any Office products. I use VI.
Slide pane. All right. Okay, we got it now.
Ask me how to do it in VI.
You use Emacs?
No.
All right, can you see the wires now?
Yes, cables.
Okay, all right. And, all right, I guess you were about
Well,
to.
let's see if he can see the next, click over the next slide and see.
Click
if he can see it.
Can you see the next slide?
Got it.
Yes.
Oh, there.
Okay.
Let's do it this way.
Okay. And we are here.
Sorry about that, Robert. Thank you for your patience.
That's all right. Illogical, even absurd, but consider that a chatty NMS element can ordinarily be safely ignored when paired with a second less common alert gives reassurance that something real is going on while confirming the system is operating normally. Is the absence of an alert a sign of comfort, or does it mean that your system has failed to detect something operating under your radar? NMS components are divided between active and passive. Passive elements listen to broadcast traffic and SNMP traps and record what they detect. Active elements scan the address space, interrogate network devices, and store the results in databases where it can be compared with information from a variety of sources. Again, redundancy is our friend. Less chance of missing something this way. Physically, my NMS is comprised of one repurposed server running Ubuntu Server 1604 and one purpose-built workstation running Linux Mint 17.3. Both systems have been rebuilt or replaced multiple times over the course of the last decade. All the software on them is either free open source software or was written by me in-house. The NMS server handles all the data storage functions as well as logging, web reporting, as well as service monitoring. It uses RANCID, a seriously tortured acronym meaning really awesome new Cisco config differ, RRD, which is round robin database, MySQL, PostgreSQL databases, MRTG, or multi-router traffic grapher, NetDisco, WMIC, the Apache web server, and the Nagios 4.11 monitoring and reporting framework with the Nagiostat reporting graphing tool. It constantly queries a long list of network devices and services and logs their states and performance metrics. Much of this log data is available in graph form via the links on the Nagios services page. Any device, server, firewall, switch, router, printer, etc., reporting a problem or whose performance metrics fall outside predetermined levels will cause the server to send an email to the appropriate IT staff notifying them of the issue. Within Nagios, formerly NetSaint and a commercial product in its current incarnation, monitored services can be categorized. Webmasters, DBAs, messaging, network, printers, desktop, and server ops are typical examples. Systems and services are classified as either routine or critical, and this is taken into account when alerts are being sent, so that important alerts can be sent after hours as text messages to cell phones, while routine messages collect in email inboxes. Nagios monitoring is done with a variety of programs, most of which are written in the Perl language. Some of these are standard Nagios plugins and check for the presence of an active device via ping or a service, FTP, HTTP, etc. Others are more limited. These are largely community contributions and may be customized to the specific needs of an organization for compatibility with existing systems or to provide greater detail or less detail than the stock version. Some of these I have rewritten to the point where only the core query function remains. In my experience, the quality of the code varies greatly, meaning there is so much room for improvement while customizing these plugins for your individual environment. Since Nagios is only a framework, its usefulness is limited only by the effort you are willing to put into deploying it. While many users only use it to alert them when a host goes offline, the true value is reaching deep into performance metrics and providing notification of pending failure. Even when run on a Linux host, Nagios can reach into a Windows box and trigger predefined tests, such as monitoring directory sizes or checking for the presence of files. The framework itself is highly customizable. This can be seen in the service config template, which I will not go through in detail, Suffice to say that there's a lot of stuff in here that you can twiddle with and tweak to your heart's content. Those things that are generally used are the host name, the check command, which is the command Nagios uses to go out and actually run the individual sensor. The check period, which tells it when it's supposed to run the checks. Process perf data, which tells it whether it is supposed to pass off the performance information it collects to other programs like Nagiostat. The notification period, which tells it when it is supposed to be emailing you about information. And the contacts list, which tells it who it's supposed to be sending those emails to. Other user-definable and customizable objects are hosts, host groups, service groups, contacts, contact groups, time periods, and commands. The command objects are the links between the Nagios framework and the library of sensor programs. Rancid is one of those single-purpose tools that operates separately from the other parts of the NMS. Its sole function is to download the running config from Cisco routers, firewalls, and switches, compare them with the previously saved version, and report via email if there are any changes. This provides automated backup, auditing, and change notification for infrastructure configurations, things that are usually low priority until a crisis occurs. Nagiostat is a graphing add-on for Nagios. While fairly elementary in function and convoluted in configuration, it does allow for on-the-fly creation and display of graphs by integrating with the Nagios services page, as seen here by the little circles. It uses RRD to store and retrieve numeric values collected by the sensor plugins. The major advantage of RRD is that each table has a fixed size that is set upon creation and does not grow as more data is added. It does this by averaging older data over longer periods and dropping anything over a year old. What you get are hourly, daily, monthly, and yearly graphs with no need to prune or maintain the data yourself. Multi-router traffic grapher is another product of the prolific Tobias Erdiker. The man page states, quote, MRTG generates HTML pages containing PNG images which provide a live visual representation of the traffic load on network links, unquote. Because the images are loaded by an HTML document that you can edit, it's possible to arrange the web page to make it easy to compare graphs of related data. The intention was to allow you to monitor the ports on a router so you can see at a glance where traffic is going and if there are any anomalies needing investigation, like someone downloading several gig at 2 in the morning. Despite its name, MRTG works equally well on switch ports. This makes it invaluable for visualizing the overall flow of traffic across your network. Just monitor the uplink ports and any port with a critical system attached. NetDisco is another standalone system that uses one daemon to manage a queue of data collection jobs and another to provide access to the collected data via a website. The data is stored in a PostgreSQL database where it can be accessed by other parts of the NMS. Because of its built-in ability to discover and correlate devices through CDP and LLDP, NetDisco is effectively autonomous. Once installed, it requires no administration and no maintenance. If you need to know what is connected to the ports of any switch in your network, the NetDisco web interface will tell you. It makes locating unauthorized, unmanaged switches on your LAN very easy. WMIC is a Windows Management Instrumentation client for Linux. It lets you, with the appropriate credentials, use WQL to interrogate almost any aspect of the Windows OS. I used it in the Perl script wmiscan.pl, run as a cron job, to check all connected Windows hosts and get a list of their installed network interfaces. With that, it's a simple matter to report who has their Wi-Fi and LAN active simultaneously, providing potentially a backdoor into the LAN. The NMS workstation is the management element, as well as running the main active process. I use it to view the web pages provided by Nagios, MRTG, and NetDisco, and to manage the headless server via SSH and SFTP. It also runs ARPWatch-NG in the background. ARPWatch-NG is a mostly passive process. It can be configured to send notifications, such as the one you see here, which is pretty much all the email looks like. But if it is used in a system as comprehensive as the one that I've described here, that isn't really necessary. Its sole function is to listen for and record ARP communications in a flat file. That file provides the MAC IP declared name and a timestamp of the first time that a MAC IP combination was seen. The workstation runs, via cron, a Perl script, in this case called camlan.pl, which is based on the camera.pl code written by Toby Erdiker, him again, that queries all network switches using SNMP for the index, name, alias, speed, and operational state of all the ports, as well as the forwarding interface index of all MAC addresses the switch knows. It saves all this information in a MySQL database created for the purpose. The script then collects data from the PostgreSQL database put there by NetDisco and the ARPWatch NG database. It ARP scans the network to see what the currently connected devices have to say for themselves. After that, it does a NetBIOS scan of the address space to add that to its collection. Once it has collected all this data, the program performs the following actions. Look for invalid or self-assigned addresses. And you see that we have one here under ARP info discrepancies. It says that there is a user with a user-assigned MAC and an IP that I have munged out, indicating a possible spoofing attempt. I know what that is, so that's not particularly dangerous. It determines what IPs belong to each MAC and looks for duplicates, determines what switch port the MAC is on, the associated IPs, the NetBIOS name, the DNS record, and the manufacturer of the NIC by identifying the OUI. If any information is missing, the program goes back and reinterrogates the device again in case it did not reply first. The final step is to correlate all this data into a nested Perl hash of arrays and scalars so that any piece can be retrieved by referring to it using values contained in other variables. This is invaluable when tracing a MAC address from the switch forwarding table to the port, to the interface, to its state, alias, status, or configuration. Here's the code. I'm not going to read it what I've got written here, so we'll just skip on past. The opstat function determines whether it's either up or down depending on the state of a port to which the device is connected. Domain is a hash that is acquired via running nvstat, nvscan. Speed and opstat are functions that it derives from knowing the MAC address, what port the MAC address is on, what interface hosts that port, and then the speed of that interface. This code here is what extracts all of those variables that are used in creating the email. Should anything untoward appear in the data, the program knows to highlight this in the report. In the actual email, it highlights things in red and various colors to indicate the status level, the danger level, and so forth. Duplicate IPs, DNS records that do not match forward and reverse lookups, devices that appear to be workstations but are not members of the local domain, and anything using an IP address not in the correct DHCP or static ranges will be reported with emphasis. Any system that is unresponsive or that fails one of the above checks will be scanned aggressively using Nmap and reported as a potential intruder. This allows members of the IT department to pick up their LARTs and march down to the location of the miscreant to perform an interrogation in a timely fashion. This is far superior to noticing that something is in your logs days later, or getting that embarrassing call from the FBI telling you that your data is for sale on the dark web. The server listens for messages from all the network component devices, switches, routers, firewalls, wireless bridges, sent using the simple network monitoring protocol. These messages are sent whenever the state of a network interface changes. If a switch interface changes from an inactive state to an active state, this triggers a custom program via the trap handle directive in the snmp trapd.conf file that performs the following actions. It does a reverse DNS lookup to obtain the DNS name registered for the newly connected device, if any, interrogates the switch for the status, speed, and description of the port the device is using, queries the database for information on what devices have been connected to this port in the past, performs a NetBIOS scan of the currently connected device, logs the information obtained, independent of later reporting decisions, determines the manufacturer of the network interface of the connecting device, determines if the connecting device is a member of the local domain, and if not, performs an intensive port scan of it to try to learn what its capabilities are and what operating system it is running. creates and emails a report containing all of the information obtained. The server listens for SNMP notifications from the firewalls that someone has connected using a virtual private network tunnel. When this occurs, it triggers a program that takes the following actions: builds a detailed report of the current state of all current VPN connections on the firewall, publishes the report through the Apache web service, queries its database to see if the connecting user has used VPN before, when, and from what IP address. If the user has not connected before or is using a different IP address than previously, the server updates its database with the current data and sends an email with the following information: username, user's IP, which firewall is the VPN endpoint, the ISP name, and if it's a cellular character, geolocation of the IP, and a list of the 10 previous VPN connections this user has made. The point of all the data is to make it easier to determine if the connection is legit or not. In fact, I had one of those just earlier this week. I had somebody connect from Texas, and I immediately called up the desktop support people and said, why is this person connecting from Texas? You know, they're only supposed to be in the state of South Carolina. Turns out they were on vacation and had very nicely taken a notebook with them so that they could check their email. So we did have someone legitimately connecting from Texas. The server uses the multi-router traffic grapher utility to report the volume of network traffic passing through the uplink and downlink interfaces connected to the private side of our firewalls and to the internet on the public side. This program records current and historic values and presents them in a set of web pages that are updated constantly. The purpose of this is to reveal and document any unusual flow of data that might be a hacker extracting information from our systems. It also makes us aware of any trends in internet usage from outside visitors and inside users and makes visible any changes in those patterns. That is worth the price of admission right there. The server uses the Rancid program to monitor the configuration of all the routers and firewalls. It constantly checks for and reports any changes made. Its purpose is to prevent someone who might gain unauthorized access to those devices from making any changes to them without anyone's knowledge. This is in addition to the config in the firewalls themselves that cause them to report each command they receive to an auditor outside of IT, as well as logging the activity to a dedicated server. Another active component on the workstation is a custom program that constantly performs a scan of all valid network addresses using the Windows Management Instrumentation Protocol to interrogate all Windows devices for the presence and absence of any wireless interfaces. When it finds a device with an active Wi-Fi interface, it sends an email alert. The point of this is to prevent someone from circumventing our network security by connecting to both our rigorously controlled internal network and one of the 24 currently accessible foreign Wi-Fi networks available at the same time. Summary. As you can see, modularity and redundancy are two key design elements of the NMS. The failure of any individual component cannot disable the entire system. This frequently means that multiple notices are generated describing different aspects of a single event. A new computer coming online will cause one part of the NMS to report an interface status change, another piece will report a new MAC address, another will query the host for its name and domain, another will check to see what ports it responds on and what operating system it is using, still another will check for an active Wi-Fi interface. Any foreign system connecting to the network will cause a storm of alerts and notices that it will be impossible to miss and difficult to ignore. This gives you the ability to investigate its presence in a timely manner. The most significant thing about this NMS is that it is not a stock one-size-fits-all product. It is constantly evolving in composition and capability as new threat vectors and exploits come to light and countermeasures or detectors can be developed. Even those parts of it built with standard utilities like Nagios are designed to be adaptable to different systems and purposes. Since every piece of code on the Linux systems is open source, any part can be modified to better suit our needs, and much of it has been. Even after 8 years of development, this is still very much a work in progress. I will make this document available. The document itself is 53 pages long. It includes pages that show the list of utilities, the list of Perl modules needed, and text of the 3 primary Perl scripts used via email. If someone wants it, they can email me, robert.lindsey@sclot.com. I thank you for your time.
Yes, thank you. And also, if you could maybe send us a link on our mailing list. Ben, if you could forward that to us.
Actually, I would rather not forward this out. I will be happy to send it to individual people on request, though.
Okay.
He's pretty concerned about security. If you haven't gleaned that yet,
Yeah.
I'll tell you, Robert, that was easily the most prepared presentation we've ever had at a Cola Lug meeting, and probably will be for a long time. Okay, Jace.
And exploits come to light, and countermeasures or detectors can be developed. Even those parts of it built with standard utilities like Nagios are designed to be adaptable to different systems and purposes. Since every piece of code on the Linux systems is open source, any part can be modified to better suit our needs, and much of it has been. Even after 8 years of development, this is still very much a work in progress. I will make this document available. The document itself is 53 pages long. It includes pages that show the list of utilities, the list of Perl modules needed, and text of the 3 primary Perl scripts used via email. If someone wants it, they can email me, robert.lindsey@sclot.com. I thank you for your time.
Yes, thank you. And also, if you could maybe send us a link on our mailing list. Ben, if you could forward that to us.
Actually, I would rather not forward this out. I will be happy to send it to individual people on request, though.
Okay.
He's pretty concerned about security. If you haven't gleaned that yet.
Yeah.
I'll tell you, Robert, that was easily the most prepared presentation we've ever had at a Cola Lug meeting, and probably will be for a long time. Okay, Jace, you had a presenter.
Yeah. David doesn't seem to be here, so.
Okay. All right, we've got a short presentation. I'm talking like 5 minutes from Shay Walters. It might go longer than that, but it probably will. But he's done a little fun stuff with the Raspberry Pi, and I think we're gonna switch the we're gonna have to switch to Sharon on the Hangouts. Okay. All right. Can you see me?
I can see Ben.
All right. Good. And
See me?
I can see Shay now.
All right. So what I'm going to do is, I've just been getting some things on eBay, and I'll post a note out to both of the mailing lists about some of the like the eBay item numbers that you can find. But I mean, they're surprisingly inexpensive. You can get, this is a device that will plug onto the Raspberry Pi.
Hold on.
Oh, yeah. Plugs onto the Raspberry Pi and gives you a breakout of all of your GPIO pins. And, it's like a regular breadboard. And they have a couple of different sizes. I mean, this one is really kind of limited functionality, and this one's a lot better. And this kit actually came with a power supply that you can set jumpers for 5 volts or 3.3 volts, depending on what kind of chips you have that you're playing around with. But again, I'll put some, I'll send some notes out on the mailing list about those. And I've got a lot of the, you can order kits that come with, like jumper cables and just like bags of LEDs and resistors and just all kind of stuff. So the one thing I wanted to show tonight is something that was very surprising to me. It's basically using a Raspberry Pi for something it was not designed for. And it is using it as an output device with one piece of hardware added to it, which is this wire. You put it on GPIO pin number 4. And what this software does is it programs a frequency generator on the fly to generate an FM radio signal. And on the Raspberry Pi Model A, it will actually do stereo FM, This one's a Model B, and it doesn't do the stereo, but it still does binaural. The program on the Model A is called PI-FM, P-I-F-M, and the one for the Model B is called FM_transmitter. So okay, so I'm gonna plug our monitor in on the Pi so I can see what I'm doing. And I mean, you know, it plays a WAV file, but now I haven't experimented around with this a lot yet, but you're supposed to be able to like pipe, run through FFmpeg and pipe it into it and play it as a WAV file. So, and it has to run with root privileges. So it's.
You want to flip the camera on to the screen? Show the screen.
I mean, I don't know. Something might come loose.
Yeah.
So I've just got a plain old, you know, FM radio here, and we'll turn the transmitter around so you can see the command line in a minute. So I'm going to run it right here. You know, and it just plays the Star Wars theme as a demonstration. So, but it's, like I said, it uses a WAV file, and you know, I just thought it was kind of cool to use something in a way that it was never designed to be used. You know, and so that was